Instead of converting between grams and moles, you might also be asked about the number of atoms or the number of particles. If you remember, okay, a mole contains 6.022 times 10 to the 23rd things. A lot of the times in science we say 6.022 times 10 to the 23rd particles. Particles is usually synonymous with atoms, or if it's a compound, molecules, or if it's an ionic compound, formula units, or even ions. But anytime you see atoms or molecules, you're using that 6.022 times 10 to the 23rd, okay? And I'm using that as a conversion factor in one of two ways. If I'm starting with number of things, if I'm starting with particles, so it might say like atoms, then I would use for every 1 mole, there's 6.022 times 10 to the 23rd atoms, and the atoms or the particles would cancel out. Okay, or if I'm starting with moles, I want moles on the bottom and particles or atoms or things on top. And we're going to take a look at this. Okay, so this is another conversion factor you can use, which represents that other mole concept, that a mole is 6.022 times 10 to the 23rd things. Okay, so how many atoms are in 2.5 moles of sodium? So I'm going to start with a 2.5, okay, mol, because that's what I have. And a lot of times you might even see me putting a formula after it to remind myself what I'm dealing with. So it's saying moles of what? Moles of sodium. And I find this helpful in some problems, especially problems that I'm doing maybe molar mass in later, to just remind me what I'm doing. But if you just write 2.5 moles, that's okay too. Okay, so 2.5 moles of sodium, all right, and I want to turn it into number of things. How many atoms? So if it's at how many atoms or how many molecules, that's a cue that I am using the Avogadro's number. I want moles on the bottom so they cancel. 1 mole is equivalent to 6.022 times 10 to the 23rd atoms. Okay, and now moles will cancel, and I'll be left with atoms. So I'm just doing 2.5 times 6.022 times 10 to the 23rd. And in my calculator, it gives me 1.5 e to the 24. Now, remember in your calculator, instead of typing in 6.022 times 10 to the 23rd, you could do 6.022 E23. And to get that E, you do the second button, and the comma button. Okay, and that turns into E, and then you would just write 6.022 E23. You don't have to write 10 anywhere. What if the question started with, rather than asking 2.5 moles, what if the question started with how many atoms are in 2.5 grams of sodium? So I can't just go from grams into number of atoms. I always have to pass through moles first. So if you notice, my conversion factor here is 6.022 times 10 to the 23rd over 1 mole. So I'm always going to have to go through moles first. So here are my conversion factors. Okay, there's 6.022 times 10 to the 23rd particles or atoms in 1 mole, and 1 mole also weighs the molar mass. So if I want to go from particles into mass, I'm going to have to pass through moles first. We always have to go through the moles bridge. So I always like to say, when in doubt, mole it out. Okay, so let's take a look at this example. The recommended daily intake of sodium is 2.5 grams. So I'm going to write that to start with, 2.5 grams. I'm just going to remind myself it's of sodium, Na. How many sodium atoms are in the sample? So I'm starting with grams, and they want atoms. I cannot go straight from grams into atoms because I don't have any value that tells me grams per atom. I do have a value of grams per mole. That's the molar mass. So when in doubt, mole it out. Let's change grams into moles first. To do that, I want something that has grams on the bottom and moles on top. I need something that relates grams to moles, and that's going to be the molar mass. What's the molar mass of sodium? If I look up on the periodic table, it has an atomic mass of 23, so that's going to go on the bottom. So 23 grams per 1 mole. Okay, grams on the bottom to cancel, moles on top. Remember, the value always goes next to grams. The 1 goes with the moles. Okay, now I'm in moles because grams cancel out. Now I can go into number of atoms using that 6.022 times 10 to the 23rd. All right, awesome. So I'm going to put moles on bottom so they cancel out. 6.022 times 10 to the 23rd atoms will go on top. And in my calculator, I'm doing 2.5 times with everything on the top divided by whatever's on the bottom, okay? And I should get 6.5 times 10 to the 22 atoms. I've changed grams into atoms, but notice I had to change it into moles first. When in doubt, mole it out. So you may have more than one conversion factor. Okay? Take a moment, try this example going in the opposite direction. Oh, no, same direction. Just give it a shot. Okay, 100 grams of octane is starting here. 100 grams C8H18. Okay, well, how can I change grams into number of molecules? Well, I don't know exactly how many molecules are in a gram. I do know how many molecules are in a mole, and I do know how many grams are in a mole. That's the molar mass. So let's go through moles first. Let's change grams into moles. So when in doubt, mole it out. Grams into moles, I need the molar mass. So for octane, okay, there's 8 C's, they have an atomic mass of 12. There's 18 H's, have an atomic mass of 1. Add that up, and I get 114. That's going to go in the bottom because I want grams to cancel out, and the 114 always goes next to G, and I want a 1 mole on top. Okay, so these cancel out, and now I have 6.022 times 10 to the 23rd C8H18 molecules for every 1 mole, because moles can now cancel out. So notice I changed grams into moles first, and then moles into the number of molecules using 6.022 times 10 to the 23rd. Remember, whenever they say how many atoms or molecules, this is the number I want to use. So here's my answer. Take a moment and give this one a try. How many molecules are in 30 grams of heptanol? So I'm starting with 30 grams, and I just reminded myself of what the formula is, and I rewrote this in such a way that I've grouped all the C's, all the H's, and all the O's together, because it might be, when doing the molar mass, I might forget there's an extra H here, so there's actually 16 H's. So the molar mass of this compound is 116, 7 C's, 16 H's, and 1 O. So that's going to go in the bottom. I want grams to cancel out, and this is going to allow me to convert between grams and moles. There's 116 grams per 1 mole of this substance. Now I can go for moles into number of molecules by using Avogadro's number, 6.022 times 10 to the 23rd molecules in 1 mole. Okay, I want moles on the bottom, and I want that number on top. And then I can get my answer by multiplying everything on top, dividing by what's on the bottoms. Take one moment and try this one. 1.39 times 10 to the 20 molecules, and I want the mass. Well, I don't have any exact form, I don't have a conversion factor that goes directly between molecules and mass, but I do know how many molecules are in a mole, so when in doubt, mole it out. Let's go through moles first. So molecules, change it into moles. There's 6.022 times 10 to the 23rd molecules in 1 mole, and now I'm in moles. Now I can figure out the mass by just using the molar mass. Add it up somewhere on the side. There's 19 C's, there's 28 H's, and there's 2 oxygens. Multiply them by their atomic masses, add it up. It has 288 grams in 1 mole. That 288 is always going to go next to grams, and I want that on top so that I'm in grams, and I want 1 mole on the bottom so that that's canceled out. As a reminder, when you're doing this in your calculator, if you're dividing by 6.022 times 10 to the 23rd, you've either got to enclose that entire number in parentheses, divide by, start parentheses, 6.022 times 10 to the 23, end parenthesis. Or if you don't want to deal with parentheses, enter that number in as 6.022E23, which you get that E by pressing second and comma. Okay, to bypass the parentheses. Otherwise, if you're putting that number in your calculator, you've got to enclose it in parentheses if you're dividing by it, because if you don't have parentheses, what your calculator is going to do is when you try to divide by this number, it's going to divide by 6.022, and then it's going to multiply your whole number by 10 to the 23rd. So that's why you need parentheses, or you have to add it in with this E button so it knows that this number is all together. Your choice. So if you want a nice visual here, as a reminder, to go between mass, grams, and particles, I've always got to pass through the mole first. When in doubt, mole it out. So if I start with moles, I can go directly into grams or particles. But to go mass to particles or particles to mass, particles meaning atoms or molecules, notice I've got to pass through the mole first. Okay? This might be a helpful graphic to look at. Take a moment, try this problem. Which of the following 100-gram samples contains the greatest number of atoms? So let's do this out for each of them. For magnesium, if I start with 100 grams, to turn it into moles, I would need 1 mole over 24.3 grams, and I would get moles. And if I needed to change this into number of atoms, I could multiply by 6.022 times 10 to the 23rd, but I'd be doing that for all the same of these. So I'm just going to turn these first all into moles and see whichever is going to have the largest number of moles would also have the largest number of atoms, because a mole always contains 6.022 times 10 to the 23rd atoms, the same number. For zinc, I would be dividing by 65.4 because that's the molar mass to turn it into moles. And for silver, I'd be dividing by an even larger number, 107.9. So what I'm going to notice is because magnesium has the lowest molar mass, I'm going to get the most moles and therefore the most atoms. So magnesium would be my answer. And if you wanted to change each of these to number of atoms by multiplying by 6.022 times 10 to the 23rd and then getting your answer, that's totally fine and acceptable and great too.